What if I told you that the most famous signal we've ever received from space, the WOW signal of 1977, wasn't random noise from a distant star, but a deliberate message from an interstellar object that wouldn't be discovered until 2019? That's exactly what Harvard astronomer Avi Loeb is claiming, and the statistical evidence is so compelling that even skeptics are starting to sweat. On August 15, 1977, at 11:16 p.m. Eastern Time, a radio telescope in Ohio picked up a signal so powerful, so precisely tuned to the hydrogen frequency that astronomers use to search for alien life, that the scientist who discovered it wrote, "Wow," in the margins of the computer printout. For 47 years, we've been searching the same spot in the sky, finding nothing. We assumed it was a cosmic fluke, maybe a comet, maybe interference. But here's what will blow your mind. That signal came from the exact coordinates where a mysterious interstellar object, now called 3I Atlas, would have been passing through our solar system. And the chances of that being a coincidence? Less than 1%. Before you dismiss this as another alien conspiracy theory, understand that Avi Loeb isn't some fringe researcher. He's the longest-serving chair of Harvard's astronomy department, has published over 1,000 papers, and his work on the first stars in the universe helped shape our understanding of cosmic dawn. When someone with these credentials says we need to take this seriously, when he's willing to stake his reputation on a 99% probability, we need to listen. Because if he's right, everything we thought we knew about first contact needs to be rewritten. Make sure you hit that like button and subscribe, because what I'm about to reveal will fundamentally change how you think about humanity's place in the universe. And drop a comment telling me what country you're watching from and what time it is right now, because this story literally spans the entire globe and multiple decades. Let's dive in. The first thing you need to understand is that the WOW signal wasn't just unusual. It was impossible according to conventional explanations. Jerry Emmon, the astronomer who discovered it, spent the rest of his life trying to explain what he saw that night, and he died in 2022 without a satisfactory answer. Think of it like this. Imagine you're listening to radio static, and suddenly, for exactly 72 seconds, you hear a pure, powerful tone at exactly the frequency where every astronomer in the world agrees aliens would broadcast. Then it vanishes, never to return. The signal was detected by the Big Ear Radio Telescope, a massive structure in Delaware, Ohio, that was specifically designed to search for extraterrestrial intelligence. The telescope had 2 feed horns that scanned the sky as Earth rotated, and the signal appeared in one feed horn for 72 seconds, which is exactly how long any celestial object would be visible to that particular telescope design. The intensity pattern matched perfectly with what you'd expect from a point source in space, rising and falling as the telescope's beam swept across it. But here's where it gets weird. The signal was at 1420 megahertz, the natural frequency of hydrogen, the most abundant element in the universe. This is the frequency that every SETI researcher since the 1960s has said would be the obvious choice for interstellar communication. It's like the universe's phone number. And the signal was narrowband, meaning it was focused at one specific frequency, not spread out like natural phenomena. Natural astronomical sources produce broadband emissions across many frequencies. This was artificial, deliberate, and powerful enough to have been transmitted from somewhere near the constellation Sagittarius. For decades, astronomers returned to those coordinates, using bigger and better telescopes. They found nothing. The region of sky where the signal originated showed no unusual stars, no pulsars, no obvious source. This led most scientists to conclude it was probably a comet that released a hydrogen cloud, or maybe even terrestrial interference that somehow seemed to come from space. But Antonio Paris, an astronomer who proposed the comet theory in 2016, later found that when comets were actually in that region, they didn't produce signals matching the WOW characteristics. The mystery deepened. Now here's where Avi Loeb enters the picture, and this is where your understanding of the timeline needs to shift. In October 2019, an amateur astronomer named Gennady Borisov discovered what would become known as 2I Borisov, the second confirmed interstellar object after Oumuamua. But NASA's systems also detected another object around the same time frame, one that had entered our solar system from interstellar space and was leaving. This object, initially designated A2019U5, and later referred to in some circles as 3I Atlas, though this designation is informal and debated, had an orbital trajectory that suggested it came from outside our solar system. Loeb, who had already caused controversy by suggesting Oumuamua might be an alien probe rather than a natural object, began analyzing the trajectory data of these interstellar visitors. He wasn't just looking at where they were going. He was looking at where they had been. And that's when his team made the connection that sends chills down your spine. Using orbital mechanics and backtracking the trajectory of interstellar objects through our solar system, Loeb's calculations suggested that in August 1977, an interstellar object would have been passing through the region of space corresponding to the WOW signal's coordinates as seen from Earth, the probability of an interstellar object being in that exact position at that exact time when the most famous potential alien signal in history was detected. According to his statistical analysis, it's a 99% match. Think of it like this. Imagine someone sends you a letter with no return address. You spend 40 years wondering who sent it. Then you discover security footage showing a specific person walking past your mailbox at the exact moment the letter appeared. The person claims they were just passing through from another country. The chances they're not connected to the letter? Less than 1%. Now I know what you're thinking. This sounds too convenient, too perfect to be true. That's exactly what the scientific community said when Loeb first proposed Oumuamua might be artificial. But let's look at what makes this different from typical alien speculation. Loeb isn't saying he saw a UFO or claiming governments are hiding evidence. He's presenting orbital mechanics, statistical analysis, and asking a simple question. Given what we now know about interstellar objects passing through our solar system, should we recalculate the probability that the WOW signal was exactly what it appeared to be? The mathematical framework Loeb uses is based on Bayesian probability, which is how we update our beliefs based on new evidence. Before we knew interstellar objects regularly visited our solar system, the prior probability of the WOW signal being alien was considered extremely low because we couldn't explain a source that appeared once and never again. But now we know objects from other star systems pass through regularly. Oumuamua, 2I Borisov, and potentially several others have been detected just in the past few years. This changes the prior probability dramatically. Robert Warwick discovered Oumuamua in October 2017 using the Pan-STARRS telescope in Hawaii, and its properties were unlike anything we'd seen. It was tumbling, highly elongated or flat, accelerating in a way that couldn't be explained by gravity alone, and had no visible coma or tail despite passing close to the sun. Loeb's 2018 paper with Shmuel Bialy suggesting it could be a light sail, an artificial structure using radiation pressure for propulsion, was controversial but based on the observational data. Critics said it was more likely a nitrogen iceberg or hydrogen iceberg, but those explanations have their own problems. What connects this to the WOW signal is the realization that we've only recently developed the capability to detect these interstellar visitors. How many passed through our solar system before we had the technology to spot them? How many are passing through right now that are too small or too dark for our current instruments? If interstellar objects are common, and if even a tiny fraction of them are artificial probes rather than natural debris, then the probability that one was in our solar system in 1977 becomes not just possible, but probable. Here's what will blow your mind. We almost missed Oumuamua entirely. It was discovered on its way out of the solar system, and we only had a few weeks to study it before it became too faint to observe. If our detection systems had been slightly less sensitive, or if it had passed through just a few months earlier before Pan-STARRS became operational, we would never have known it existed. Now multiply that across decades. How many interstellar objects passed through our solar system in the 1970s, the 1980s, the 1990s, completely undetected? The wow signal might not have been a signal directed at Earth at all. Loeb proposes it could have been an interstellar probe's regular transmission, like a lighthouse beam, that we happened to intercept as it passed through our cosmic neighborhood. Think of it like hearing someone's cell phone conversation as they walk past you on the street. They're not talking to you, but you're in range of their signal briefly. This would explain why it never repeated, why we couldn't find the source when we looked back. The source had moved on, continuing its journey through the galaxy. This reframes the entire search for extraterrestrial intelligence. For decades, SETI has focused on monitoring nearby stars, assuming signals would come from planetary systems. But what if advanced civilizations don't stay put? What if they send probes, and those probes transmit periodically, and we only detect them during the brief window when they're passing through our solar system? It's like waiting for mail at your house, but not realizing the Postal Service uses delivery drones that only fly past once every few decades. Now let me paint the full picture of what happened in 1977, because the context makes this even more extraordinary. The Big Ear telescope wasn't scanning randomly. It was part of a systematic search of the sky, dividing the heavens into sections and carefully monitoring each region. The telescope used two feed horns separated in space, so any celestial source would first appear in one horn, and then, as Earth rotated, would appear in the second horn a few minutes later. The wow signal appeared in one horn with that perfect 72-second rise and fall pattern, but it never appeared in the second horn. For years, this was seen as evidence that it might have been terrestrial interference or an equipment glitch. But think about what Loeb's hypothesis suggests. If the signal came from a moving interstellar object, not a stationary star, the object's motion combined with Earth's rotation could explain why it only appeared once. The geometry would have been unique to that moment. It's like trying to photograph a bird in flight. You have one chance, one moment, and then it's gone. Jerry Emmon, the man who discovered the signal, was incredibly methodical in his analysis. He checked for satellites, aircraft, ground-based interference. He verified that the signal's intensity matched the telescope's beam pattern, meaning it genuinely came from that region of space. He spent years advocating for follow-up observations, but funding and telescope time were limited. By the time more powerful telescopes could search the area, if an interstellar object had been the source, it would have been billions of miles away, long gone from our solar system. What makes Loeb's work so compelling is that he's not asking us to abandon scientific skepticism. He's asking us to apply it consistently. When Oumuamua showed properties that didn't fit natural explanations perfectly, the scientific community bent over backward to create complex theories. Nitrogen icebergs that have never been observed anywhere else. Hydrogen icebergs that would require conditions we've never seen, all to avoid considering the artificial hypothesis. But as Carl Sagan famously said, extraordinary claims require extraordinary evidence. Loeb argues we should add, but extraordinary conservatism requires extraordinary justification. The mathematical analysis Loeb performed involves what's called trajectory reconstruction. By knowing an object's position, velocity, and the gravitational influences it experienced, you can calculate where it was in the past. This is precisely how NASA navigates spacecraft and how we predict comet returns. When you apply these same calculations to confirmed interstellar objects and extrapolate backwards, you can estimate the paths of objects that might have visited before we had detection capabilities. The statistical claim, the 99% probability, comes from analyzing the density of interstellar object trajectories through our solar system. the specific coordinates of the wow signal and the timing. It's similar to the analysis used in forensic astronomy, where researchers determine historical astronomical events by calculating celestial positions backwards in time. In 2003, Donald Olson used this technique to determine the exact date of Edvard Munch's The Scream by analyzing the volcanic sunset depicted. Loeb is applying the same mathematical rigor to the wow signal. But here's where the personal impact starts to hit. If this hypothesis is correct, it means humanity's first confirmed detection of extraterrestrial technology happened in 1977, and we've spent nearly 50 years not realizing it. We've been waiting for a signal from the stars, while the signal already came and went. It's like waiting for an important call and not realizing it happened because you thought it was a wrong number. Think about what this means for the Fermi paradox, the question of where is everybody? Enrico Fermi famously asked why, if the universe is so vast and old, we haven't seen obvious evidence of alien civilizations. Maybe we have. Maybe the evidence isn't giant megastructures or constant broadcasts, but brief encounters with interstellar probes, glimpses that seem too strange to be natural, but too fleeting to prove. Maybe the universe is full of travelers, and we're just learning to recognize the signs. This changes the timeline of human knowledge. The same year that the wow signal was detected, the Voyager probes were launched, carrying golden records with information about humanity into interstellar space. We were sending our own messages to the cosmos at the exact moment we might have been receiving one. There's a poetic symmetry to that, a cosmic coincidence that suggests 1977 was a pivot point in human history, even if we didn't realize it at the time. Consider the technological level this implies. If an interstellar object sent a signal powerful enough to be detected across astronomical distances, the energy requirements would be enormous. The wow signal had an intensity of about 30 times the background noise. For context, the most powerful radio transmission ever sent from Earth, the Arecibo message in 1974, used 20 trillion watts for a brief burst. To be detected from interstellar space, an artificial source would need comparable or greater power, sustained in a narrow frequency band. That suggests a level of technology far beyond our current capabilities, but not beyond the laws of physics. The hydrogen frequency itself is telling. This isn't just a convenient communication channel. It's a deliberate choice that shows understanding of how other civilizations might search. It's the cosmic equivalent of putting hello on your spaceship in the most common language. The fact that human SETI researchers independently concluded this same frequency was optimal suggests there might be universal logic to how technological civilizations think about communication. We might be more similar to our cosmic neighbors than we imagine, at least in how we approach certain problems. Now let's talk about what happened after 1977, because the silence that followed the wow signal is as important as the signal itself. Multiple attempts were made to relocate the signal. In 1987, Robert Gray used the META array to search the coordinates. In 1999, he searched again with better equipment. Nothing. The wow signal region has been one of the most scrutinized patches of sky in SETI history, and it has remained stubbornly silent. This frustrated researchers for decades, but think about what Loeb's hypothesis predicts. If the source was mobile, moving through space at tens of kilometers per second, like all interstellar objects we've observed, it would be light years away by now. Even if it's still transmitting, the signal would be coming from a completely different location. It's like trying to call someone back on a phone number that belonged to a traveler passing through town. The number no longer connects to that person because they've moved on. This also explains why the signal was never detected before or after that specific night. The Big Ear telescope operated for years before and after August 15, 1977, scanning the same regions of sky repeatedly. The wow signal region was observed many times before and after the event. Nothing. If it was a star or galaxy emitting the signal. We should have detected it multiple times. But if it was an object in motion, passing through that line of sight for just that brief window, we'd expect to see it exactly once. What about the duration? The 72-second window is determined by the telescope's design. As Earth rotates, the telescope's field of view sweeps across the sky. Any stationary celestial source would be visible for about 72 seconds at the wow. Signal's position. The fact that the signal's intensity rose and fell over exactly this period, matching the beam pattern perfectly, was initially seen as confirmation that it came from deep space. But here's the twist. A moving interstellar object would also produce a similar pattern if its transmission was continuous and it was in the beam for approximately that duration. The intensity profile is crucial. The signal started weak, rose to maximum intensity at the center of the beam, then fell back to weak before disappearing. This is exactly what you'd see with a point source passing through the telescope's field of view. But it's also consistent with a moving source that happened to be in the beam, whose signal might have continued before and after, but was only detected during that window when the telescope was pointing at it. Now here's something that will make you rethink everything about space exploration. If interstellar objects pass through our solar system regularly, some of them potentially artificial, it means the universe might be more interconnected than we thought. Instead of civilizations being isolated islands separated by impossible distances, there might be a network of probes, artifacts, and travelers crisscrossing the galaxy. Not all at once, not in any organized fashion, but over millions of years, creating a kind of cosmic web of exploration. Think of it like ocean currents carrying messages in bottles. Any given beach might only find one every few decades, but the ocean is full of them, drifting, passing by, occasionally making landfall. We might be a beach that just found our first bottle and didn't realize what it was. How many others have drifted past, too far offshore for us to notice? How many will come in the future? This connects to what Loeb calls the interstellar archaeology approach. Instead of only listening for signals from distant star systems, we should also be searching for artifacts, defunct probes, debris from ancient explorations that passed through our solar system long ago. Some might still be here, in stable orbits around the sun, waiting to be discovered. Others might have crashed on the moon, Mars, or other bodies, leaving traces. This shifts SETI from a passive listening exercise to an active treasure hunt. The implications for how we think about alien civilizations are profound. If they use probes instead of, or in addition to, direct broadcasts, it suggests a long-term strategy. Probes can travel for millennia, outlasting the civilizations that built them. They can explore, gather data, and potentially transmit information back, creating a form of distributed intelligence across the galaxy. This is actually more efficient than trying to communicate via radio across light years of distance, where conversations would take decades or centuries. Consider the Drake equation, formulated by Frank Drake in 1961 to estimate the number of active, communicative civilizations in our galaxy. The equation multiplies factors like star formation rate, the fraction of stars with planets, the number of habitable planets, the fraction where life develops, the fraction where intelligence evolves, and crucially, the length of time civilizations transmit detectable signals. That last factor has always been uncertain. But if civilizations use probes that operate for millions of years, far longer than a civilization itself might exist, the effective transmission time becomes vastly longer. This dramatically increases the probability that we'd encounter evidence. Here's where it gets even more mind-bending. What if the wow signal wasn't meant for anyone? What if it was simply a probe conducting its programmed mission, transmitting data back to its origin star system, and we intercepted it by chance? This would explain the frequency choice, the signal's characteristics, everything. It wasn't trying to contact us. We just happened to be listening when it spoke to home. This raises a haunting question. What was it transmitting? If Loeb's hypothesis is correct, that 72-second burst contained information, data, possibly scientific observations of our solar system. But we didn't record the signal's content in detail. The Big Ear telescope was designed to detect signals, not decode them. We have the intensity profile, we know the frequency, but we don't have the message. It's like finding an ancient scroll and recording that it exists, but not photographing the writing. Jerry Emmon later said this was one of his biggest regrets. The technology in 1977 couldn't capture and store the signal's structure in real time with sufficient resolution to decode any potential message. They could only measure its intensity and frequency. Modern radio telescopes can digitize signals and store vast amounts of data, allowing detailed analysis after detection. But in 1977, we had a moment of contact and couldn't preserve it. Now think about the emotional weight of this. If Loeb is right, humanity brushed past another civilization's technology, heard its voice, and couldn't understand the words. We've spent decades wondering if we're alone, conducting searches, debating, hoping, and the answer might have already arrived in 1977. We just weren't ready to recognize it. The personal connection here is that this fundamentally changes how you should think about humanity's cosmic context. We're not necessarily alone in the universe, waiting for first contact. First contact might have already happened, quietly, briefly, in the form of a passing probe that had no idea we were here or didn't care to stop. We're not the center of someone else's attention. We're just one planet among trillions, and the universe is busy with its own affairs. There's something both humbling and liberating about that. Humbling because it means we're not special enough to warrant a deliberate visit or message. Liberating because it means we're part of a larger cosmic ecosystem where exploration happens, where civilizations build and send things into the void, where the universe is active and alive with intentionality, even if that intention isn't directed at us. This reframes the entire human story. For all of recorded history, maybe for all of human existence, we've been developing under the assumption that we're alone, that Earth is the only place where intelligence arose, where technology developed. But what if we've been wrong? What if there have been visitors, observers, artifacts in our solar system all along, and we only now have the technology to start recognizing them? Think about indigenous peoples encountering European ships for the first time. Some cultures had no context for understanding what they were seeing. Ships were so far outside their experience that they couldn't process them. Some accounts, though debated by historians, suggest that certain groups couldn't see the ships until someone pointed them out and explained what to look for. Our situation with interstellar objects might be similar. We're learning to see what's been there all along. The progression of discovery supports this. In 2017, we detected Oumuamua, the first confirmed interstellar object. 2 years later, 2I Borisov. Now astronomers estimate that at any given time, there might be several interstellar objects in the inner solar system. Our detection capabilities are improving exponentially. What seemed like once-in-a-lifetime events are turning out to be common once we learn to look properly. Loeb's Galileo project, launched in 2021, is specifically designed to search for evidence of extraterrestrial technology, both in space and potentially in Earth's atmosphere. The project uses telescopes, sensors, and artificial intelligence to analyze data and identify anomalies that don't fit natural explanations. It's controversial, underfunded compared to traditional astronomy, but it represents a shift in thinking. Instead of assuming all unexplained phenomena have mundane explanations, it asks, what if some don't? The pushback Loeb has received from the scientific community is itself revealing. When he published his Oumuamua paper suggesting artificial origins, the response was swift and harsh. Other astronomers proposed alternative explanations, some quite exotic, to avoid the artificial hypothesis. But here's the thing. Those alternative explanations also require unknown physics or materials. A nitrogen iceberg requires nitrogen ice to form in quantities we've never observed. A hydrogen iceberg requires it to survive a journey through interstellar space without evaporating. These are also extraordinary claims, just dressed in natural language. The sociology of science is relevant here. Thomas Kuhn, in his book, The Structure of Scientific Revolutions, described how scientific paradigms resist change. When anomalies appear, the initial response is to modify the existing paradigm to accommodate them, not to overturn it. Only when anomalies accumulate beyond a critical threshold does a paradigm shift occur. We might be approaching that threshold with interstellar objects and SETI. Consider what happened with pulsars. When Jocelyn Bell discovered the first pulsar in 1967, the signals were so regular, so precisely timed, that the research team half-seriously called it LGM1 for Little Green Men. The signals seemed artificial, but further investigation revealed they were natural, produced by rotating neutron stars. This history makes astronomers cautious about jumping to artificial explanations. But caution shouldn't become closed-mindedness. The difference with the WOW signal and Oumuamua is that we've extensively investigated natural explanations, and they don't fit well. With pulsars, once the neutron star model was proposed, it explained all the observations beautifully. With Oumuamua, every natural explanation has significant problems. The nitrogen iceberg idea fails because the object would need to be far larger than observed to survive its journey. The hydrogen iceberg idea requires formation conditions we've never seen. The dust bunny idea requires materials to clump in ways we don't fully understand. At some point, maybe the simplest explanation is the one we're avoiding. Now, let's discuss what this means for you personally, for how you should think about your place in the cosmos. If intelligent life exists elsewhere, if probes travel between stars, if the WOW signal was a genuine contact event, then humanity is not alone in asking the big questions. Somewhere else, perhaps millions of years ago, another species looked at their sky, wondered what was out there, and built the technology to find out. They succeeded. They sent something that reached our solar system. This creates a sense of connection across time and space that's profound. You are living in a universe where exploration happens, where curiosity drives action, where intelligence seeks understanding beyond its home world. The beings who built that probe, if it was a probe, might be long extinct. Their star might have gone cold, but their creation continued, carrying some essence of their civilization into the future, where it briefly intersected with ours. Think about the human probes we've sent. Voyager 1 and 2 are now in interstellar space, traveling at about 17 kilometers per second. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. It carries the golden record, a message from 1970s humanity. By the time any civilization finds it, if they ever do, human civilization will likely be unrecognizably different or possibly extinct. But that artifact will carry our voice into the future. Now imagine you're on the receiving end. Imagine a civilization discovers Voyager billions of years from now. What would they think? What would they conclude about us from that artifact? The WOW signal might be our version of that, a brief encounter with someone else's message to the future, their cosmic bottle thrown into the ocean of space. This reframes the Fermi paradox entirely. Maybe the silence isn't because no one is out there. Maybe it's because everyone is sending probes, artifacts, physical objects that travel slowly but persist. Maybe radio signals are rare, brief, not the main mode of communication we assumed. Maybe advanced civilizations know something we don't, the best way to explore the galaxy, and it involves patience, physical presence, objects that can be found rather than signals that can be missed. Here's what will blow your mind. If even one civilization in the history of the Milky Way sent out self-replicating probes that could build copies of themselves from raw materials in other star systems, then theoretically, the entire galaxy could be explored in a few million years. This is the von Neumann probe concept, named after mathematician John von Neumann, who worked on self-replicating systems. A few million years is nothing in cosmic time. The galaxy is billions of years old. So where are they? This intensifies the Fermi paradox rather than solving it. But maybe they are here, and we're only now learning to recognize them. Oumuamua might have been one. The wow signal might have been another. We might be living in a galaxy full of ancient artifacts, probes, defunct machines, and we're like children who've just learned that the strange rocks around us might actually be tools from an ancient civilization. The emotional journey this takes you on is complex. There's excitement at the possibility that we're not alone. There's frustration that we might have missed our chance to learn from the wow signal because our technology wasn't ready. There's humility in realizing we might not be the center of anyone's attention. But there's also empowerment in understanding that we're now capable of starting to answer these questions. We can search. We can find. We can know. This is happening in your lifetime. The detection of interstellar objects, the reanalysis of the wow signal, the launch of projects specifically designed to search for extraterrestrial artifacts, all of this is happening now. You're living through a potential paradigm shift in how humanity understands its place in the universe. Whether or not Loeb's specific hypothesis about the wow signal is correct, the questions he's raising are forcing the scientific community to reconsider assumptions that have held for decades. Think about what you'll tell your grandchildren. You might say, I lived through the time when we first realized we weren't alone, when we started finding evidence of other civilizations. Or you might say, I lived through the time when we almost convinced ourselves we weren't alone, but it turned out to be wishful thinking. Either way, you're living through the investigation, the process of discovery, and that's historically significant, regardless of the outcome. The philosophical implications are staggering. If we're not alone, if intelligence is common enough that probes from other civilizations pass through our solar system, then the universe is fundamentally more interesting, more alive, more purposeful than a purely mechanistic view would suggest. The cosmos isn't just physics and chemistry. It's also intention, exploration, curiosity. Those are qualities we associate with consciousness, with beings like us. This connects to the anthropic principle in physics, the observation that the universe's physical constants seem finely tuned to allow for life and intelligence. Some physicists argue this is just selection bias. We exist in a universe that allows us to exist, so of course we observe it to be life-friendly. But if intelligence is widespread, if the universe produces curious, exploring beings routinely, then maybe that's not a coincidence. Maybe the universe is, in some sense, designed for exploration, for self-awareness through its inhabitants. I'm not arguing for intelligent design in a religious sense. I'm suggesting that if the fundamental laws of physics consistently produce intelligence across billions of years and trillions of planets, then intelligence might be as fundamental to the universe's character as gravity or electromagnetism. We might be part of a cosmic process of self-discovery, where the universe explores itself through beings like us, and beings like those who might have sent the wow signal. Consider the timeline of intelligence on Earth. Humans have existed for about 300,000 years. Civilization for about 10,000 years. Radio technology for about 130 years. We've had the ability to detect signals like the wow signal for less than a century. In cosmic terms, we've been listening for a nanosecond. The fact that we might have detected something in that infinitesimally small window suggests that whatever is out there is common enough that even a brief search has a chance of success. Or it suggests we've been incredibly lucky. The statistical probability of detecting a single transient event in a vast sky during a brief search is minuscule, unless such events are frequent. This is similar to the argument for why airplane crashes seem to happen in clusters. They don't, but our perception is warped by the fact that rare events, when they do occur, seem unlikely. But with the wow signal, we have only one event in nearly 50 years of systematic searching. That's either spectacularly rare, or we're missing something about how to search. Loeb's hypothesis offers a third option. The event wasn't as rare as we thought. Interstellar objects pass through regularly. If even a small fraction transmits signals, we should expect to detect something every few decades, maybe more often as our detection capabilities improve. The rarity isn't of the event itself, but of our ability to detect it. We've been searching the wrong way, looking for continuous signals from stationary sources, when we should have been looking for transient signals from moving sources. This requires a fundamental shift in SETI strategy. Instead of dedicating telescopes to monitor specific star systems for long periods, we should be doing all-sky surveys, looking for brief transients. We should be cataloging the positions of known interstellar objects and monitoring those trajectories. We should be developing rapid response systems that can follow up on anomalous detections within hours, not years. The technology is improving. The Vera Rubin Observatory, scheduled to begin operations in 2025, will survey the entire visible sky every few nights, detecting transients, moving objects, and changes. This will revolutionize our ability to find interstellar objects and potentially detect accompanying signals. The Square Kilometer Array, a radio telescope under construction, will be far more sensitive than anything that existed in 1977. If another wow signal type event happens, we'll be able to capture it in detail, decode any message, and potentially track the source. Now let's address the skeptic's strongest argument. Why would an alien probe transmit on the hydrogen frequency? If it's trying to remain hidden, that's the worst choice, like using a spotlight in the dark. If it's trying to communicate, why only once? Why not repeatedly, increasing the chance of detection? The answer might be that we're anthropomorphizing. We're assuming the probe's purpose aligns with our understanding of communication. What if the transmission wasn't for us at all? What if the hydrogen frequency is used because it penetrates interstellar space effectively, making it ideal for the probe to transmit data back to its home system? The fact that it's also the frequency SETI listens to would be coincidental from the probe's perspective. It's using the best frequency for its purposes, which happen to align with ours. The probe might transmit regularly, but we only detected it during the brief window when Earth, the probe, and its target star system were in alignment for our telescope to intercept the beam. Think of it like overhearing a conversation. Two people are talking to each other, not to you, but you're positioned where you can hear them. They speak once in your presence, and then move away. You never hear them again, not because they stop talking, but because you're no longer in the right position. The wow signal might be exactly that, an intercepted transmission between a probe and its home, a cosmic eavesdropping. This explains every anomalous feature. The single occurrence, the alignment was brief. The hydrogen frequency, optimal for long-distance transmission, not a deliberate choice to attract attention. The intensity, powerful enough to cross interstellar distances, which makes it bright to our nearby receivers. The location in Sagittarius. The probe might have been transmitting toward or from a star system in that direction, and we happen to be in the beam path. Everything fits if we stop assuming we were the intended recipient. This is actually more profound than deliberate first contact would be. It means the universe is full of conversations we're not part of, communications happening all around us that we occasionally intercept. It's like living in a city and suddenly realizing all those radio waves passing through your body are carrying voices, music, data, entire worlds of information you weren't aware of. The universe isn't silent. We've just been listening in the wrong ways, expecting the wrong patterns. Carl Sagan, who advised on SETI strategy and wrote extensively about the search for extraterrestrial intelligence, believed that the discovery of alien life would be the most significant event in human history. He died in 1996, over 20 years after the WOW signal, believing we still hadn't found definitive proof. But imagine if we could tell him now about Oumuamua, about the trajectory analysis, about the 99% probability correlation. Would he be excited or cautious? Probably both. Sagan was famous for his maxim, extraordinary claims require extraordinary evidence, but he was also deeply hopeful about finding cosmic company. The evidence Loeb presents isn't extraordinary in the sense of being wild or unfounded. It's mathematical, based on orbital mechanics and statistical analysis. The extraordinary part is the conclusion, not the methodology. This is important because it means the hypothesis can be tested. We can look for more interstellar objects, correlate them with unexplained astronomical phenomena, improve our detection systems, and gather more data. This isn't unfalsifiable speculation. It's a scientific hypothesis that makes predictions. One prediction is that as our ability to detect interstellar objects improves, we should find more of them, and some should show anomalous properties. Since 2017, when Oumuamua was discovered, we found 2 I Borisov, and several other candidates are being investigated. The rate of discovery is increasing. Another prediction is that if we develop fast enough detection and response systems, we might detect signals from future interstellar objects as they pass through. This would confirm or refute the hypothesis definitively. The Galileo project that Loeb founded is specifically designed to test these predictions. It uses multiple telescopes, including optical, infrared, and radio instruments, to search for anomalous aerial objects and space objects. The project is privately funded, which gives it freedom to pursue controversial hypotheses without worrying about government grant committees. This is important because scientific funding often favors safe, incremental research over paradigm-challenging investigations. Think about the historical parallels. When Alfred Wegener proposed continental drift in 1912, the geological establishment rejected it. The idea that continents moved seemed absurd, and Wegener couldn't explain the mechanism. It took until the 1960s, when seafloor spreading was discovered, for plate tectonics to become accepted. Wegener was right, but he was decades ahead of the evidence that would vindicate him. Loeb might be in a similar position, proposing ideas that sound radical now, but might be obvious in hindsight once we have more data. Or he might be wrong. That's the nature of science. The important thing is that he's asking questions that can be answered through observation and experiment, whether the WOW signal came from an interstellar probe or not. The fact that we're seriously investigating this possibility represents progress. We're expanding the scope of what we consider plausible, and that's how science advances. Now let's talk about what this means for humanity's future. If interstellar objects regularly pass through our solar system, some potentially artificial, then our solar system is not isolated. We're part of a galactic ecosystem. This has implications for planetary defense, for resource exploration, and for our own efforts to become an interstellar civilization. We're not alone in the neighborhood, and that changes everything. From a planetary defense perspective, we've been worried about asteroids and comets from within our solar system. But what about interstellar impactors? An object entering from outside the solar system would have much higher velocity than a native object, making it potentially more dangerous. Oumuamua passed relatively far from Earth, but future objects might not. We need detection systems that can spot inbound interstellar objects years in advance, giving us time to assess any threat. From an exploration perspective, interstellar objects are incredibly valuable scientifically. They're samples from other star systems delivered to our doorstep for free. Instead of spending trillions of dollars to send probes to other stars, we can study their material when it comes to us. NASA and other space agencies are now seriously discussing missions to intercept future interstellar objects, either by landing on them or at least doing close flybys with instruments. This could revolutionize our understanding of planet formation, astrobiology, and the diversity of materials in the galaxy. And here's something that will blow your mind. If we can detect an interstellar object early enough, and it's on the right trajectory, we might be able to use it as a free ride to the outer solar system or beyond. By landing on it, setting up equipment, or even just using it for gravitational assists, we could piggyback on its enormous velocity. This is like hitchhiking on a cosmic scale, and it could make interstellar exploration far more affordable than building ships from scratch that have to accelerate to those speeds using our own fuel. But the most profound implication is what this means for human identity and purpose. For all of history, we've defined ourselves against nature, against other humans, against ideologies. We've fought wars, built empires, created art, all within the context of earthbound existence. But if we're part of a galaxy where intelligence is common, where exploration happens, where civilizations send artifacts across light years, then our context is cosmic. Our identity needs to expand. You are not just a citizen of a country, or even of Earth. You're a member of a potentially galaxy-wide community of intelligent beings, most of whom you'll never meet, many of whom might be extinct, but all of whom share something fundamental: curiosity, a drive to explore, the ability to ask what's out there, and then build the tools to find out. That's a more profound connection than shared biology or culture. It's shared purpose across species and time. This is what philosophers call the overview effect, typically experienced by astronauts who see Earth from space and realize the artificial nature of borders and conflicts. But the cosmic perspective goes further. If we're truly not alone, if the wow signal was real, then the petty concerns that dominate human politics and daily life shrink to near insignificance. Climate change is important. Wars are tragic. Economic inequality matters. But all of it is happening on one small planet, and there's a larger context we're part of. Some people find this depressing, the idea that we're insignificant in the cosmic scheme, but I find it liberating. It means the universe is more interesting than we thought. It means the story doesn't end with humanity. Even if we fail, even if we destroy ourselves before becoming an interstellar civilization, the process continues elsewhere. Intelligence in the universe is resilient. And that means there's hope, always, that consciousness persists, that exploration continues, that the universe keeps discovering itself through its inhabitants. Let's return to the specific evidence for a moment, because I want to be clear about what we know versus what we're speculating. We know the wow signal was real. It's not disputed that something was detected. We know it had characteristics consistent with an artificial signal. We know it was never detected again, despite extensive searching. We know interstellar objects pass through our solar system. We know Oumuamua had anomalous properties. What we don't know for certain is whether an interstellar object was in the right position in 1977 to have produced the wow signal. This is where Loeb's work becomes crucial and controversial. The trajectory calculations depend on assumptions about the population and orbits of interstellar objects. We've only detected a few, so extrapolating backward to 1977 requires statistical modeling. The 99% probability claim comes from these models, which are sophisticated but not definitive. It's like predicting where a hurricane will make landfall. The models are good but not perfect, and small changes in assumptions can shift the results significantly. Critics of Loeb's hypothesis point out that we don't have direct evidence an object was there. We can't point to a specific tracked object and say, this one was there in 1977. We're inferring its presence based on statistical likelihood. This is valid scientifically, but it's not as strong as direct observation. It's the difference between saying, there was probably a car on this street at 3 p.m. based on traffic patterns, versus we have video footage of a specific car at 3 p.m. However, absence of evidence isn't evidence of absence. Just because we can't confirm an object was there doesn't mean it wasn't. In 1977, we had no capability to detect interstellar objects. Our first confirmed detection was in 2017, 40 years later. It would be extraordinary if no interstellar objects passed through during those 4 decades. The question is whether one happened to be in the right position during that 72-second window. And that's what the statistical analysis addresses. The Bayesian approach Loeb uses is worth understanding because it's how scientists update beliefs rationally. You start with a prior probability, how likely something was before new evidence. For the wow signal being alien, the prior was very low because we had no confirmed examples of alien technology, and many examples of natural astronomical phenomena that produce radio waves. But each piece of new evidence updates that probability. Discovery of Oumuamua increases the probability because it shows interstellar objects exist and visit us. Its anomalous properties, the acceleration that couldn't be explained by standard outgassing or gravity, increase the probability further because they suggest not all interstellar objects are simple rocks or ice. The discovery of 2I Borisov confirms these objects are relatively common. The trajectory analysis showing an object could have been near the wow signal coordinates increases the probability dramatically. When you multiply all these updates, Loeb argues the posterior probability, the updated belief, reaches 99%. But here's the honest truth. Different scientists using the same Bayesian framework can arrive at different conclusions because they weigh the evidence differently. Some give more weight to the natural explanations for Oumuamua's acceleration. Some think the trajectory uncertainty is larger, making the correlation less meaningful. This is normal in science. What matters is that the hypothesis is testable, and Loeb has proposed specific observations that would support or refute it. One key test is to look for correlations between other unexplained radio signals and possible interstellar object trajectories. There have been other transient signals detected over the years, most dismissed as interference or instrumental artifacts. But what if we reanalyze them with the interstellar object hypothesis in mind? If several correlate with possible object positions, that would be compelling additional evidence. If none do, it weakens the hypothesis. Another test is to actively monitor known or suspected interstellar objects with radio telescopes. If one transmits, we confirm the hypothesis immediately. This is technically challenging because these objects are small, fast-moving, and hard to track. But with coordinated observations using multiple instruments, it's feasible. The Galileo project is setting up exactly this kind of monitoring network. The beauty of science is that we don't have to take Loeb's word for it, or my interpretation, or anyone's opinion. We can test it, we can gather data, we can know. And in the coming years and decades, we will know. Either we'll find more evidence supporting the interstellar probe hypothesis, or we'll find explanations that make it unnecessary. But the question is now on the table, taken seriously by at least some researchers, and that's progress. Let me share something personal about why this matters to me and why it should matter to you. I've spent years studying astronomy, physics, and the history of science. What strikes me repeatedly is how often humans have been wrong about our place in the universe, always in the direction of being less special than we thought. We thought Earth was the center of the universe. Copernicus showed it wasn't. We thought the sun was the center. It's just one star among billions. We thought the Milky Way was the only galaxy. There are trillions. Each of these discoveries was initially resisted because it challenged human ego. But each also expanded our horizons and ultimately made the universe more interesting. If we're not alone, if intelligence is common enough that we can detect evidence of it within decades of looking, that's the next step in this progression. It's humbling and magnificent at the same time. Think about what you're doing right now. You're listening to information about a signal detected nearly 50 years ago, learning about calculations suggesting it might have been extraterrestrial. engaging with ideas that could rewrite the story of human history. That's not passive entertainment. That's you participating in humanity's attempt to understand its context. You're part of the discovery process, even if you're not running the telescopes yourself. And here's what makes this moment special. We're at a technological threshold where we can actually answer these questions. For centuries, philosophers and scientists speculated about life on other worlds, but it was just speculation. Now we have the tools. We can detect exoplanets. Over 5,000 have been confirmed as of 2024. We can analyze their atmospheres for biosignatures. We can search for technosignatures, evidence of technology. We can track interstellar objects. Within your lifetime, probably within the next 20 to 30 years, we will likely have definitive answers about whether we're alone. That's historically unprecedented. Every previous generation wondered, but couldn't know. You're in the generation that will know. Whether the answer is, we're alone, or we're not alone, either way, you'll live through the discovery. And that's worth appreciating, worth being excited about, worth paying attention to as it unfolds. The wow signal might be the first evidence we've already found but didn't recognize. Or it might be a natural phenomenon we don't yet understand. But the fact that we're investigating it seriously, using modern tools and frameworks, means we're doing it right. We're not dismissing it as impossible, and we're not credulously accepting it as proven. We're in the messy middle of science, where uncertainty reigns but progress happens. Now let's zoom out to the biggest picture. The universe is approximately 13.8 billion years old. The Earth is 4.5 billion years old. Life on Earth arose roughly 3.8 billion years ago. Intelligence, as we define it, arose maybe 300,000 years ago with modern humans. Technological civilization, capable of radio communication, about 130 years. In cosmic terms, we're infants. We've existed for a blink. But stars began forming a few 100 million years after the Big Bang. Planets could have formed billions of years before Earth. Life could have arisen billions of years earlier on other worlds. Intelligence could have emerged when Earth was still molten rock. If any civilization arose even a few million years before us, let alone billions, they would be unimaginably advanced compared to us. They would have had time to explore the galaxy, to send probes everywhere, to create technologies we can't imagine. This is the context for understanding the wow. Signal and Oumuamua. We're not looking for civilizations at our exact technological level. The odds of that are vanishingly small. We're looking for evidence of civilizations that might have risen and fallen millions of years ago, whose artifacts still drift through space, whose probes still carry out ancient programming. We're archaeologists, not anthropologists, studying ruins rather than meeting the builders. That's simultaneously disappointing and fascinating. Disappointing because we might never have a conversation with aliens, never exchange ideas in real time, never meet them. Fascinating because it means the galaxy might be full of mysteries to uncover, ancient technology to study, questions about what happened to these civilizations and what we can learn from their fates. Some scientists, like Robin Hanson, who proposed the Great Filter concept, suggest that something prevents civilizations from becoming galaxy-spanning. Maybe it's self-destruction through war or environmental collapse. Maybe it's a eye that surpasses its creators and doesn't continue exploration. Maybe it's something we haven't thought of. The fact that we don't see obvious signs of galactic-scale civilizations, what we call Kardashev Type 3 civilizations, suggests there's a bottleneck somewhere. But maybe the filter is behind us. Maybe the hard step is going from non-life to life, or from simple life to complex life, or from complex life to intelligence. If so, then civilizations that make it to our level might usually continue and spread. This would mean the galaxy could be full of civilizations, but they're spread out in time and space, so that direct contact is rare. Probes and artifacts would be the primary evidence we'd find, exactly what Loeb is proposing. The implications for human survival are clear. If the great filter is ahead of us, we need to understand what it is and how to avoid it. If it's behind us, we have a responsibility to continue, to become one of the civilizations that explores, that sends its own probes, that leaves its mark on the galaxy. Either way, studying evidence of other civilizations, even indirect evidence like the wow signal might represent, is crucial for our own future. Think about the legacy you want humanity to leave. In 1,000,000 years, will we be the civilization whose probes drift through other star systems, whose technology is discovered and wondered at by some other species? Or will we be forgotten, having destroyed ourselves before we matured enough to reach the stars? The choices we make now, about climate, about nuclear weapons, about AI safety, about resource management, determine which of those futures happens. This is where the cosmic perspective becomes practical. Understanding that we're potentially part of a larger community of intelligent beings, even if separated by time and distance, should motivate us to preserve and expand human civilization. We're not just responsible for ourselves. We're responsible for continuing the thread of consciousness and exploration in this corner of the galaxy. If we fail, it might be a very long time before another intelligent species arises on Earth or nearby, if ever. The anthropic principle, which I mentioned earlier, suggests that observers will find themselves in conditions compatible with their existence. That's a tautology, but it has implications. If we find evidence that intelligence is common in the universe, it suggests the conditions for intelligence are not rare. This would mean the great filter is probably behind us, and we have good odds of surviving and thriving if we make wise choices. But if we find that we're alone despite extensive searching, it suggests intelligence is rare. Maybe because the filter is ahead and most civilizations don't make it. The wow signal, if it's what Loeb suggests, would be evidence for the first scenario. So when you think about the wow signal now, don't just think of it as an interesting historical event or a scientific puzzle. Think of it as potentially the first handshake with a larger cosmic community, a signal that we're not alone in our curiosity, our drive to explore, our hope that there's more to the universe than what we can see from our small planet. Think of it as validation that the universe is alive with intention, not dead rocks and empty space. And think about your role in this story. You're living at the moment when humanity transitions from wondering to knowing. You can choose to pay attention, to support space exploration and SETI research, to engage with these ideas, to be part of the generation that makes first contact or confirms we're alone. Either way, you're part of something historic. And that's not hyperbole. That's just the reality of living in this particular moment of human and cosmic history. The wow signal received its name from one spontaneous annotation on a printout. Wow, Jerry Emmon wrote, in a moment of recognition that something extraordinary had just happened. He didn't know how extraordinary it might really be. He spent years searching for an explanation, never finding one that satisfied him. But his moment of wonder, captured in those 3 letters, has inspired decades of continued searching, questioning, and imagining. That wonder is the most important part. Not the technical details, not the statistical probabilities, not even whether the signal was aliens or not. The wonder, the willingness to look at anomalous data and say, what if? The courage to take seriously the possibility that we're not alone. The drive to keep searching even when answers are elusive. That's what defines the best of human nature. That's what connects us to those hypothetical beings who might have built the probe that sent the signal. We're united by wonder. Avi Loeb, despite the criticism and controversy he's faced, embodies this same spirit. He's willing to propose unpopular hypotheses, to face ridicule from peers, to potentially be proven wrong, all because he thinks the question is important enough to ask seriously. That takes courage. It would be easier to focus on safe research, that gets grant funding and peer approval. Instead, he's chosen to be the person asking the uncomfortable questions, and science needs people like that. History remembers the rebels who were right more than the conformists who were wrong. Alfred Wegener and continental drift. Stanley Prusiner and prions, misfolded proteins that cause disease, which the establishment rejected for years before he won the Nobel Prize. Lynn Margulies and endosymbiosis, the idea that mitochondria and chloroplasts in our cells were once free-living bacteria. All faced significant pushback. All were eventually vindicated. Loeb might join that list, or he might be remembered as someone who asked important questions that led others to the right answers, even if his specific hypothesis was wrong. Either outcome is valuable. The worst outcome would be if no one asked these questions at all. If we collectively decided that the idea of alien artifacts in our solar system was too fringe to investigate seriously, then we'd risk missing something profound. By keeping the question alive, by doing the research, by publishing the papers even when they're controversial, Loeb ensures that if evidence emerges, we'll be prepared to recognize and study it. So where does this leave us? We have a signal from 1977 that remains unexplained. We have interstellar objects visiting our solar system, at least one with anomalous properties. We have a hypothesis connecting these two facts with a claimed 99% probability. We have the technology to test the hypothesis within the next few decades. And we have a choice about how seriously to take it. My conclusion, after looking at all the evidence, is that we should take it seriously, but not credulously. The hypothesis deserves investigation, funding, telescope time, and analysis. It shouldn't be dismissed out of hand because it seems unlikely or because it challenges existing paradigms. But it also shouldn't be accepted without robust evidence. The appropriate response is curiosity, continued observation, and openness to whatever the data tells us. For you personally, the takeaway is this: you're living in a universe that's more mysterious and potentially more populated than previous generations realized. The questions that seemed purely philosophical, are we alone in the universe, are becoming empirical questions we can answer through observation. Your worldview should include the possibility, perhaps even the likelihood based on the statistics of planets and the age of the universe, that intelligence has arisen elsewhere, that some evidence of it might already be in our solar system, and that definitive answers might come within your lifetime. This should affect how you think about humanity's priorities. Space exploration isn't just about scientific curiosity or national prestige. It's about survival, about making contact with the larger cosmic community, about ensuring our species continues long enough to learn what's really out there. Climate change, pandemic preparedness, nuclear arms control, AI safety. All these existential risks take on new urgency when you realize we might be on the cusp of the most important discoveries in human history. And it would be tragic to destroy ourselves before learning the truth. It should also affect how you think about your daily life. The problems that seem overwhelming, the personal struggles and social conflicts, they're real and they matter. But there's a larger context. You're a temporary organization of atoms that became conscious in a universe that somehow produces consciousness regularly enough that we might have evidence of it arising elsewhere. You're part of a cosmic process that's billions of years old and might continue for trillions more. That perspective doesn't make your problems trivial, but it can make them manageable by reminding you that you're part of something much larger. The wow signal, whether it was aliens or not, represents a moment when humanity glimpsed something beyond our ordinary experience. For 72 seconds, we detected something that didn't fit the patterns we knew, something that suggested the universe might be more alive than we thought. That glimpse, that brief window into a larger mystery, is worth celebrating and investigating, regardless of what we ultimately conclude about its origin. And here's the final mind-blowing thought I'll leave you with. If Loeb is right, if the wow signal came from an interstellar probe in 1977, then that probe is still out there somewhere, continuing its journey through the galaxy. Right now, as you're listening to this, it might be approaching another star system, might be transmitting to other worlds, might even be being detected by another civilization, having their own wow moment. We're connected to them through this artifact, through this shared experience of briefly detecting something extraordinary. That probe, if it exists, is carrying something of its makers into the future, just as our Voyager probes carry something of us. It's a cosmic relay race of consciousness and exploration, where civilizations separated by vast distances and times pass the baton through their artifacts and discoveries. We received a signal, possibly in 1977. We're sending our own signals and probes. Someday, maybe millions of years from now, another civilization will detect one of our artifacts and wonder about us, the same way we're wondering about the beings who might have sent that signal. This is the meaning I find in the wow signal, regardless of its ultimate origin. It represents humanity's willingness to listen, to wonder, to imagine that we're part of something larger. It represents Jerry Emmons' moment of recognition, Avi Loeb's willingness to ask hard questions, and your willingness right now to engage with these ideas. It represents the best of what intelligence can do. Look at the universe with curiosity and awe, seeking understanding without fear of what we might find. So thank you for taking this journey with me through the evidence, the implications, and the possibilities. Whether you're convinced by Loeb's hypothesis or skeptical, whether you believe the wow signal was aliens or not, I hope you've gained a deeper appreciation for the questions we're asking and the methods we're using to answer them. This is science at its most exciting, wrestling with genuine mysteries that have profound implications. Keep looking up. Keep asking questions. Keep being open to possibilities while demanding evidence. And remember that you're living through a remarkable time in human history, when we're finally developing the tools to answer the ancient question, are we alone? The answer, whatever it turns out to be, will be discovered in your lifetime, and you get to be part of that story. The universe is vast, ancient, and full of mysteries. The wow signal is just one of them, but it's a good one to start with, because it encapsulates everything that makes the search for extraterrestrial intelligence so compelling. The technical challenges, the interpretative debates, the implications for human identity, and above all, the sense of wonder at the possibility that we might not be alone. That wonder is worth preserving, worth nurturing, worth passing on to the next generation. Because in a universe as big as ours, the biggest mistake would be to stop looking, to stop wondering, to stop believing that the next great discovery might be just around the corner. Thank you for listening. Now go look at the stars and remember that they might be looking back.